Okay, so in this question, we've got effectively we've got elemental arsenite, and that's reacting with sodium hydroxide, and it forms effectively sodium orthoarsenite, Na₃AsO₃, and hydrogen. Before I go into the the details of the question, one of the things you would notice from this is the fact that this is what might be called a redox reaction, but beyond that, when you look at the one of the products, the sodium orthoarsenite, so that's the Na₃AsO₃. You may want to look that up and find out a bit more about it. It's a very toxic. Actually, you may not want to look that up, to be honest. It's quite a toxic substance. It has carcinogenic effects. It's can cause rashes, stomach pain, vomiting, diarrhea, nervous system damage, paralysis, and well, I think I'll stop there because but it's a nasty substance. But anyway, the focus is actually on the balancing of this equation, so I'm going to focus on that. Okay, so what have we got here? So we've got we've been asked to give our answer only in terms of our balancing, the final answer only using whole numbers, right? So how am I going to approach the question? The first thing I'm going to do, I'm going to take account of well, the left hand side and the right hand side, both specifically in terms of well, how many times does each element occur on either side. So this is kind of an audit process. I'm going to audit how many times each element occurs to help me with the balancing process. So I would invite you to have a go at that. So in my case, what I'm going to do, actually, I'm going to do the left hand side. So this is the reactant side, right? And then right hand side, so RHS. So that's for the side of the products. And so we've got arsenic, and then we've got sodium OH. So I just do AS NaOH, right? Okay, so let's take a look at what we actually have on the left hand side. So we've got for AS, we've got effectively it occurs once, right? So you just got one. For sodium, again, it occurs once. Oxygen occurs once, and hydrogen occurs once. Okay, so for the right hand side, so for AS here, it occurs once, right? Sodium occurs 3 times, and for oxygen occurs 3 times, and for hydrogen we've got just a H2 here, right? So that occurs twice, right? Okay, so as we can see from this auditing process, what we've kind of shown is that the only thing that really is ostensibly balanced is the arsenic, right? But that's that's not where we need to get everything balanced. So one of the things I'll look at first of all is the sodium, right? And as you can see on the right hand side, we've got 3 times as much sodium as we have got on the left hand side, right? So one of the first things I'm going to do is effectively to make this the sodium, specifically in terms of the sodium, I'm going to add a 3 in front of the NaOH on the left hand side here, right? And my goal in doing that, of course, is to try and get the sodium to be equal on both sides, right? So if I do that, what are we going to get? So the new equation would be As plus 3 NaOH produces Na₃AsO₃ plus H2, right? Now, we've not changed anything on the right hand side, so our count when we do the next stage of the auditing process will more or less be the same, right? So I can just keep that in view. So for right hand side, it's just going to be the same as this, right? So As NaOH, right? So that's going to be 1, 3, 3, 2. And on the left hand side, so we need to pay quite close attention because we have made a change which, as you can see, it doesn't just affect sodium, right? As NaOH, right? Okay, so let's take a look at what's so As is not really affected here, so we just got 1 for the As. For Na, however, you can see we've got the 3, right? So that's going to be 3. And then for the oxygen and the hydrogen, similarly, we're going to have 3. And for hydrogen, we're going to have a 3 as well, right? Okay. So at this stage, what do we notice? Well, as you can see, the arsenic is balanced, the sodium is balanced, even the oxygen is now balanced, but the hydrogen isn't, right? What we have is a situation where there's 3 hydrogens on the left hand side and only 2 on the right hand side. So, well, how would we balance this? Fortunately, in this instance, we actually have molecular hydrogen, so we have H2, right? And that makes things very easy to kind of adjust the number of hydrogens without affecting any of the other elements which are already balanced in the equation, right? And so what do we need to modify that by? Well, if we divide the larger number by the smaller one, so this is the number of hydrogens on the left hand side by the right hand side. So if we do, that's going to be 3/2, right? Of course, that's going to give us 1.5, right? So this is the multiplier that we need to bring into our equation on the right hand side in order to make things balanced. So if I add that coefficient in front of the hydrogen, the molecular hydrogen, let's see what we get, right? So we're going to do As plus 3 NaOH produces Na₃AsO₃ plus 1.5 H2. Okay, so as you can see, we've not actually modified anything on the left hand side in this particular iteration, so we can just kind of effectively copy this and say, well, that is going to be the outcome on the left hand side, right? So for on this side, we've got 1, 3, 3, 3, right? And on the right hand side, the only thing we've changed is the hydrogen. We've added the 1.5 in front of the H2, right? So that's basically the only thing that's different. and hydrogen does not occur in the in this, right? So okay, and so yeah, so we're gonna have 1, 3, 3, and so now we're looking at this which we just added. So 1.5 times H2, right? So that's effectively what, 3/2 times 2. So of course the 2's will cancel out, and we're just going to get 3, right? So right. So now you can, as you can see, if you look at the left hand side and the right hand side, we've got the same numbers, you know, for arsenic, for sodium, for oxygen, for hydrogen, 1, 3, 3, 3, both sides. However, here's the thing, we've not really got our final answer yet, and the reason for that is because the question very specifically asks us, please only use whole numbers when balancing the equation above, right? Unfortunately, although we've got this to a state where it is technically balanced, it's balanced in a format that doesn't really adhere to the full requirements of the question. So we need to make an adjustment that such that the requirements actually met. So how am I going to do that? Well, a very straightforward way is to simply multiply everything by 2. If we do that, of course, the 1.5 is going to get eliminated, right? Because then it's going to be 3. So that is exactly what I'm going to do. So we're going to have 2As plus, and so here we had 3 NaOH, multiply that by 2, we're going to have 6 NaOH, right? And then that produces, so in this case, we're going to put 2 in front of it, because obviously the coefficient, when there's no coefficient written, is 1, right? So 1 times 2 is 2, so Na₃AsO₃ plus, and then that's going to be 3H2, okay? Right. Okay. So beyond that, one of the other things we're going to do now is we're going to just do the last set of auditing, right? So we're going to just check what we actually have here. So for left hand side, effectively all we did is really doubled everything. So it's pretty straightforward, but we're going to just look at it anyway. So As NaOH, right? So we've got so As, 2As, Na, we've got 6Na, and 6O, well, 6O, 6H, right? And similarly on the right hand side, As, NaOH, right? So for As, we've got 2As, right? So, and then Na3 times 2, so that's going to be 6. O3 times 2, so that's going to be 6 as well, right? And then H2 times 3, so that's going to be 6. So as you can see, this is still balanced, right? We've just multiplied everything by 2, eliminated the stray 1.5, which didn't quite conform to what the question required. And so this is in effect our balanced equation. So if you go back here, we can effectively say, okay, well, it's going to be we can say that the balanced equation is effectively going to look like that, right? Okay. And one last note, and that would be specifically pertaining to our one of our reactants, sodium orthoarsenate. Definitely don't try this don't try this reaction at home. But anyway,